we'll be concentrating on polygon fill area. That means suppose if you draw the any images on the picture on the screen here, that picture has to be filled with some color or the pattern here. That is what we call that as an the filled area. That area is called as a filled area. So in order to fill that, if that images is filled with some pattern here, what pattern it's going to be filled here? That is what we are going to concentrate on this particular the topic. So here in this chapter, we'll be concentrating on the different types of the polygons, and after that we'll see what type of we are testing and what type of the polygon it is. Then we'll see the polygon table, how it is going to be draw the images, or the polygon is going to be formed. Then plane equation, and we'll also concentrating on the front and back polygons. Then apart from that, we'll also be concentrating on polygon fill area functions, fill area attributes, then fill area attribute functions, and general scan line polygon fill algorithm. So these are all the topics that we are going to study. So this scan line polygon fill algorithm, the same concepts is also be there for your lab session. So that is the polygon fill area algorithm. It's a 6th or 7th program year. Okay. So next is next we'll take up with the fill area primitives. As I told that as soon as when you are drawing an images, as we know that the images has to be drawn using actually the points or the straight lines and the curves here. So then after drawing the images, that image inside that image area will be and filled with some pattern here, filled with some it has to be filled here. That is how it is going to be filled. It is to be filled with either by using some solid color or with the pattern. That means any images are filled with solid color or the pattern here. That filled area, that what where it is going to be and filled with area or the pattern, that we usually called as an the filled area, or you can fill area, or we can also call this as an the filled area here. So here in this case, you can see here, you can see the human face here. You can see here in this case, the human face, as after drawing the human face, inside that human face, you can see that some area, all these areas has been filled here. You can see here, the first diagram is filled with some pattern here, and next is also you can see that filled with area some pattern here, some nose, and also as well as the eyes are is going to be highlighted in the sense here that particular the area is filled with some more pattern here. And next diagram also you can see that, so the eyes and also as well as the nose and the mouth here also again it is to be filled with some more pattern here. So now the question is that, so these arbitrary shapes and curves surface are of this is called actually the polygon facets. That means here the outer diagram is called actually the polygon facets, or now this particular the images has been filled with some polygon here. How it is going to be filled here, and what actually the pattern is filled with this particular the face of a human here. So always whatever the pattern, whatever you are going to fill with the area of the any images in the computer graphics, these all the images are filled by using actually the polygon here. What exactly the polygon? You can see this is in first diagram also you may have the polygon. Some more polygon has been more number of, that means small polygon has been filled with second diagram, again for the third diagram also. So these are all actually called actually what is this whatever you are seeing dot everything is to be called as a polygon here. That means this is filled with the polygon mesh here. And this entire the diagram or the translation, that means here first diagram only small some less number of polygon has been filled. Next is actually again some more, and next is some more here. So this entire the concept, this called actually the surface tessellation. That means filling more number of an polygon mesh with an any images is called actually the surface tessellation here. Now I told that polygon. Now the question is that what do you mean by the polygon? The polygon means polygon means that any figure or any plane figure is made up of minimum by using minimum 3 vertices. That means it is made up of 3 or more vertices, whatever the images that you are going to draw. If that images are called, actually when we say that the polygon means that if it made up of the minimum 3 vertices, means for example, let us take here, I'll show you what is that polygon. See here, for example, here 1, 2, 3. It consisting of 3 vertices. This is called actually the polygon. Or else, if it consisting of 4 vertices, this is called actually the polygon. And this line is not actually called as the polygon here. Got it? The polygon means that it consisting of minimum 3 or more vertices. That is called actually the polygon. And these vertices are actually the connected by using in straight lines. This is we call this as and what exactly edges. This is called polygon, and this is called polygon, and this is called polygon. Like that, that means the polygon means what? Understood now? What do you mean by the polygon now? Polygon means what? Polygon means what? Polygon means what? I'm asking you, what do you mean by polygon now? What do you mean by polygon? What do you mean by polygon? Hello?
Yes, ma'am.
What do you mean by polygon? I'm asking you, what do you mean by polygon?
Ma'am, any shape with more 3 or more vertices.
It consisting of what exactly? Any figure that is specified by set of 3 or more number of coordinate or the more number of vertices, or which is called actually the polygon, and these vertices are connected by using straight line, and this is called actually the what? The edges. Got it now? Now we got it. What is the polygon here? Now the next topic is, we'll see what is the type of the polygons are there. So mainly there are two types of the polygon. That is, first one is convex polygon and second one is concave polygon. And degenerate polygon, in the sense the vertices, that means the polygon or the figure which consisting of less than less than three vertices, which we usually called actually the three degenerate, means for example line or overlapping lines. These are all actually lines are called as a degenerate here. So there are two types of polygon. You have to note down along with me. Uh, Two types of polygon. That is, one is convex polygon and another one is concave. See here, this diagram, it shows the convex and concave polygon here. So this is actually the pentagon. The pentagon means which consisting of and the five vertices here. So you can see that if the interior edges, you can see in the first diagram, convex here, if the interior angles of the polygon is less than 180 degree, then it is an convex. Or else if it is greater than 180 degree, it is called actually the concave. Any one of the interior edges is greater than 180 degree, then we still called it as and what exactly? The concave polygon. Got it now? There are two types of the polygon. That is, one is convex and another one is concave. Convex means the interior angles of a polygon are less than 180 degree, then it is an convex. If the interior angles of the polygon is greater than 180 degree, then it is called, then we say that it is an concave polygon here. Then degenerate means that if any polygon or which is consisting of the less than three vertices, then we call this as an what exactly? The type degenerate polygon here. Now you got it? What do you mean by polygon and what are all the different types of the polygon? Next, Suppose assume that if I'm drawing in one complex object here, that complex object has to be what exactly? The filled with the some polygon here. It may be actually the concave polygon or it may be the convex polygon. Next, how A1, B3. So according to this, A3 is 0, 0 multiplied by any number is 0 itself. Then A1 is what exactly? 3. B3 is what? B3 is 0. Again, it will be 0, 0 itself. Got it? Then what about for the Z? Z is equal to, so A1, B2 minus A2, B1. What is the value for the Z? A1 is 3, B2 is 2. So you'll be getting 6 minus A2 is what exactly? A2 is 0 and B1 is 2. So that is 0 itself. 0. Sorry, the value will be 6. So with respect to the Z components, that is how you are going to write E1 cross E2 with respect to the Z coordinate, whether it is an greater than 0 Z value or less than 0. We have to concentrate on with respect to the Z component. So here the X is 0, Y is 0, but Z is whether Z is greater than 0 or not. Z value.
Yes, ma'am.
Which is greater than 0. Like that, we need to perform for what exactly? Perform for all the cases here. Is this clear? Is this clear how you are going to perform? So according to that, when you do like this, E1 cross edge vector of E1 and E2 with respect to the Z is greater than 0. Like that, if you do for E2 and E3 with respect to the Z, which is also comes the greater than 0. Then E3 cross E4 with respect to Z is also greater than which is less than 0. If you want to, you can continue for the same thing for all the things, edge vectors. Then E4 cross E5 is again greater than 0. Then E5 cross E6 with respect to Z is greater than 0. Then finally E6 cross E1 with respect to Z is greater than 0 itself. You can see that second step is over. The second step is what? Compute the cross product of adjacent edges. If all the cross product give the same sign here. You can see this is greater than 0, this is greater than 0, this is also greater than, but this is not what exactly less than 0. So if all are same, then it is an convex. Otherwise, what exactly? Otherwise, it is an concave. Now you tell me, it is whether it is an convex polygon or it is an concave polygon now.
Concave.
It is an concave polygon. Why? Because the one sign are different here. That is what here we have solved the problem. You can see here. So E1 cross E2 with respect to the Z is greater than 0. Again E2, E3 with respect to the Z is greater than 0. E3, E4 with respect to Z is less than 0. E4, E5 with respect to Z is greater than 0. Remaining all are in, but only E3 with E4 is less than 0. So one is different. So that here all all the signs are not all the sign are not equal here. So then we conclude that the polygon is an concave polygon here. Got it, students? This is how you are going to perform the edge vector cross product test. Definitely you'll get a question even in the internals or in the external also. They'll give the vertices and they'll ask you to find out whether it is an concave polygon or convex polygon using an edge vector cross product test here. Is this clear? Is this
Yes,
clear?
ma'am.
Yeah.
Yes, ma'am.
Now let us solve one problem. Take down all of you. Consider a triangle that is simple convex polygon defined by V1, E1, yes, given vertex V1 is 1, 1, V2 is 5, 1, and V3 is 3, 4. I'll give you 5 minutes time. You tell me whether it is an convex polygon or it is an concave polygon. All of you do it.